Okay, so let's switch gears. We'll go away from increasing, decreasing, and extrema to this next concept of whether we have an even function or an odd function. So that's our next order of business in 3.3. Again, it's pretty visual, but it does have some algebra behind it. But let's approach this visually first, get a sense, and then we'll go do the algebra next. So let's review a little bit. If you recall, back in, I believe it was chapter 2, we talked about symmetries, right? And so do you remember what type of symmetries we had to look for and to test in this college algebra class? All right, and hopefully you guys are thinking, well, there was symmetry about the point, the origin. There was symmetry about the y-axis. And there was symmetry about the x-axis. So those are the three types of symmetries that we have actually studied, all right, with regard to earlier graphs. However, we are now talking about functions. So when we're talking about functions, it turns out that one of these three we got to throw out because it's no good in terms of a function. So let me let you guys think for a moment. Which one of these three, as far as a function is concerned, do we have to throw out? Okay, you guys have the answer, right? If you're leaning towards the x-axis, you are right. This is the one we have to throw out because here's a classic graph that is symmetric with the x-axis, right? The mirror image, the picture above the x-axis is the same as the picture below. But if we do that, it now fails the vertical line test. So this is a non-function. So to be symmetric about the x-axis means we're non-function, but we are talking about functions. So the only two symmetries that we have to consider as far as functions are concerned are symmetries around the origin and symmetries about the y-axis. And it turns out that if you are symmetric about the y-axis, you are what we call an even function. Right? That has nothing to do with the degree, degree 2, degree 4, or anything like that. It's just a name that we give. I don't know why they chose to call it that, but it's a name that we give for something that is symmetric about the y-axis. So there's a definition. If we're symmetric about the origin, that means we're dealing with an odd function. Again, a lot of students mistakenly think that has to deal with a fifth degree polynomial or whatnot. Maybe it does, maybe it doesn't. It's just the definition is if you are symmetric about the origin, you're what we call an odd function. If you're symmetric about the y-axis, you're what we call an even function. So it's all about the symmetry, and then we basically use the definition. So let's go ahead then for each graph. Let's determine, right, which ones are even, which ones are odd, or which ones are neither. Again, even, we're talking about symmetry about the y-axis. Odd, we're talking about symmetry around the origin. We're not considering the x-axis, so if we're neither one of those, we're neither. So looking at this line, right, it's not a mirror image across the y-axis, and if I kick this over 180 degrees, it's not the same picture that we have. All right, so so this is not, well, let's make sure, right? So if I kick this, if I took this point, flipped it, and flipped it, yeah, I'd be over here. All right, and if I took, let's say, this data point and flipped it, I'd be over there. So if we did the double flip, we'd get that graph over here, right? So it's not symmetric about the origin, and it's not symmetric about this. So this function, this line, is neither. All right, the next function, we do see that along the y-axis, the picture on this side is symmetric with that side. So it does have symmetry around the y-axis. So what type of function are we looking at here? This is an even function. All right, so even functions are symmetric about the y-axis. The next function, if we were basically, again, let's move a point around. So 3, 1, if we moved it and slapped it over here, oops, its mirror image is over there. All right, let's take another point. If we took this point and double flipped it, right, we get the same value. So this one seems to be going through that 180 degree rotation. I did a double flip for 2 points, and they both basically mirror image each other. So this does look like it's symmetric about the origin, which means this is an odd function. Here, there is a symmetry going on, right? There is a line where the graph is symmetric, but we have to be symmetric about the y-axis or about the origin. So this one is neither. So it's neither even or it's not odd. Here we do have symmetry about the y-axis. So this is an even function. And then last but not least, if we flip this down and over, all right, or took this point up and over, right, this seems to be symmetric about the origin. So we are odd. So the new language, the old idea is the idea of symmetry. And again, we're isolating on 2 around the origin, the y-axis. So that's old. The new idea is what we're calling these functions now. Anything symmetric about the y-axis is even, these two guys in the middle. Anything symmetric about the origin are called odd functions. And then if you're neither, you're neither. Okay, so there's the visualness. We're going to now set the stage for the algebra of this. How do we algebraically test whether a function is even or odd? And we're going to revisit our symmetry test. But see you in the next video.